Perhaps you know that I am more or less always busy with looking into old radio magazines from the 1960s and the 1970s, and I have saved some of these old circuits and I want to show them now. For instance, this is such an old circuit, a grounded base transistor that is has certain properties. I cannot elaborate further on the typical properties of the grounded base transistor circuit, but this is a good circuit and usable. They've used here a PNP transistor. You can also use an NPN transistor, and in that case, of course, the voltage here must be changed to positive 9 volts. Anyway, I think it's a very interesting schematic. Another interesting schematic out of these old books. What's this? I'm more or less sure, but I am sure this is an oscillator circuit made with, again, PNP transistors, but you can indeed change them to NPN transistors. For instance, the BC547 both times, and in that case you need here, of course, not negative 3 volts, but you need here a positive 3 volt, and in that case you have a negative here and you can ground the circuit. Very interesting circuit again from the old school. This is an OC72, that is a germanium transistor. It is an oscillator circuit, of course. In these old books and schematics, you often see that they use two voltage supplies. Here a 3 volt and here a 1.5 volt. That is, in my opinion, a kind of thought back to the very early days of transistors. And also say the very old explanations of how a transistor works. But this is indeed a germanium transistor. PNP here. You can use a modern transistor. You can try to use a modern transistor, an NPN transistor. In that case you have to flip here the voltages. So the batteries must be reversed, and this is important, output terminals here, they are not indicated here, but use a 1 kilo ohm resistor, take the signal out via that 1 kilo ohm resistor. Again, same circuit, and they tell here high impedance phones. That means that's approximately 2000 ohms. So replace it with a resistor of 1 kilo ohm or 2 kilo ohm, etc. Same problem. 6 stages from only 3 transistors. Well, it's a radio circuit, that's absolutely sure. Also from the 1960s or so. So I leave it as it is, because there's more to tell. What's this? This is a 3-transistor reflex receiver, and I have in the past talked a little bit. Oh, that's not going good. Oh well. Oh. Well, anyway. Well, here I can get to the right picture, the right schematic. So, It's a reflex receiver. I have to say, I never made a reflex receiver. I've made many other radios. I've made super heterodynes and TRF radios. Many of them are on my YouTube channel. But anyway, this is an interesting circuit. And here are all the components. These are often, again, like I tell, in those days, they used PNP transistors. In 3 times, by the way. And well, you can change them into NPN transistors, but in that case, the voltage here must be positive. And all the electrolytics here and here must be reversed in that case. Anyway, interesting circuit. Of course, we now live in 2026. You can buy a radio via Ali or whatever for €5 or so, $5, etc. No need to make it, but interesting also for study purposes. Next to the schematic. Well, this is how to make an IF transformer. I cannot elaborate now on that because that is a little bit too complicated to explain that all. But anyway, here also a radio circuit. This is of course very, very interesting. A circuit of an amplifier. The values are here. R1 must be 6.8 kilo ohm. Again, PNP transistors, and the AD140 was a power PNP germanium transistor. I cannot advise to make this circuit. It will take too much current, etc., etc. But for, say, experimental ideas, it can work very, very well. And you can change this, for instance, to a power NPN transistor, say the BD139, and also here a BD139. Of course, you have to supply that circuit via a positive voltage here, because a BD139 and the other BD139 is a NPN Silicon transistor, and these are germanium transistors. PNP germanium transistors, also a good advice. Never use here an electrolytic capacitor. Use a, say, 2 microfarad or 1 microfarad non-polar capacitor, because it can leak current from the preceding stage into the first transistor. And with a non-polar capacitor here, you don't have that problem. Anyway. Well, what's this? Constant current circuit. Well, there are many, many constant current circuits on the World Wide Web and on other locations. You more or less always see the idea that there is a constant voltage that is, say, constant between, say, the base and the emitter, and that leads to a constant current. I have one or two constant current circuits on my YouTube channel, experimental. They were tested, etc., etc. So I don't elaborate further on that. Say, the whole idea of a constant current circuit is a sea to drink. Often also, say, the standard LM regulators, 6 volt, 12 volt, are used to make constant current circuits. What's this? The crystal oscillator. Well, that's interesting. Here are the components. This is a crystal, quartz crystal. There is on my YouTube channel a crystal test oscillator that goes from very low frequencies, say 1 megahertz, up to 20 or 15 megahertz, and you can find it when you go to my channel trailer via the looking glass and say type in keywords like crystal or crystal oscillator or oscillator. You can find that. This is a so-called Pierce oscillator because the collector here is, via the collector, the crystal is connected to the base. And that's a Pierce oscillator. What's this? Complete 3-stage micro power amplifier. There is a video on my YouTube channel about this amplifier, so I don't have to elaborate. And it had many views, say 3,000 or so. Anyway, here we have, what's this? Transistorized graded meter. Well, this is the schematic. Graded meter is in fact very simple. It is an oscillator that oscillates on a very broad frequency band. And this is, there must be, say, a test coil here, that's here. And when you move that coil to, this is a tuned circuit, when you move that tuned circuit here to another tuned circuit, the oscillator will, say, suck up some energy out of that external coil, the coil to be tested, and then the pointer of the meter moves. So you know that in that case the resonance of this coil and the coil to be tested are the same. Well, so next schematic. Well, a basic multivibrator circuit. Multivibrator circuits are common and still now in 2026 used everywhere, also in computers. This is of course, say, the basic circuit. It's made again all old school circuit with PNP transistors here. You can make it with NPN transistors here. In that case, again, this must be positive here, positive voltage here, and this will be negative and grounded, and this cap must also be reversed. So the positive must be here and the negative must be here. They use here diodes. And they are there to, say, make the waveform much sharper so that the transistors switch very sharp. Frequency is set by these two values of these two capacitors, and of course by the resistors that go to the base of the two multivibrator transistors. That's here 100K and also here 100K. When you change them, the time during which they are switched on and off changes. Well, sawtooth generator with tubes. I can skip it. What is this? Well, I skip it. Supply splitter. That's interesting. When you make an op-amp circuit, they often need a positive and a negative voltage supply. And this is the way to generate two voltages out of one positive negative voltage supply. I'm on 15 minutes on my camera, so my video will suddenly stop. If so, that is what it is anyway. So to the next circuit. Bootstrapped. Well, bootstrapping means that the input here of the amplifier is very high compared to the standard input of a 2 transistor stage. 4 mega ohm. That's what is told here. I don't know why they use here an electrolytic. It is an emitter follower. Well, I leave it as it is. Next schematic. The large and the small. Well, that's of course very important when we look at capacitors, resistors. What does it mean? What means 100 nanofarad for a capacitor? That is 0.1 microfarad. What does 10 picofarad mean? Well, that is more or less, as far as I know, 1 millionth of a farad, or 1/10 millionth of a farad. Anyway, oh, this is an old schematic by myself. This is how, say, in the 1960s they used transistors here and then a transformer to drive the transistors. It was a kind of, say, 2 transistor output stage, where they used 2 power transistors and an electrolytic and a double voltage here, but that's completely obsolete. Anyway, here the same ID, here the same ID. I save it because I perhaps want to do experiments with these circuits. Well, what's this? Well, method of using the alarm without a relay. Well, anyway. What's this? Again, how to use a stable, well, this is perhaps a non-stable multivibrator, but anyway. Miller integrator, I cannot elaborate now, but you go to the World Wide Web and type in on Google Miller integrator. You will find everything. Double voltage supply, very, very basic. Well, this is again the same schematic of a small transistor amplifier that I have already published. Well, I will stop now. Thanks for watching. It is a very long video, but all these schematics out of the 1960s and the 1970s are simple, easy to make, useful for every hobbyist, and especially when you want to do experiments. These circuits are extremely interesting. Thanks for watching again.